Hello slewers and welcome to Slew's Practical Astronomy series with me, Paul Cox, where we're going to learn to explore space together and get the most out of our Slew membership. So welcome to everyone this evening. Well, it's this evening here anyway in Connecticut here at Slew HQ. So I know we've got listeners around the world. Now, if you're somewhere on Slew's website and you're suddenly hearing my voice, hop over to the Situation Room and you can watch the live cast there. So you just hop over here up to Space Situation Room, and there we've got that lovely infinity thing I've got, you know, it's picture in picture in picture in picture kind of thing. Anyway, you can also, by the way, if you are doing other stuff and you want to concentrate without my voice, you can come up to the little audio widget at the top of the page and you just mute me if you like, but hang around and listen if you can, because we're covering some great topics tonight actually, and a lot of people have asked me to cover these particular ones. But before we get into those, don't forget that Helen Avery is going to be on air in an hour and a half. That's at 9 p.m. Eastern. That's 0100 UTC for the latest episode in her Constellation Stories. Now let's take a look, see what Helen is covering tonight. So left-hand navigation, live cast, and you can go down to the page and there's Helen's show. Virgo. Okay. You know, I don't really know very much about Virgo. The only thing I really know about Virgo is how many Messier objects are in the constellation of Virgo and between Virgo and Leo. If you remember, we're looking at that because that's one of the packed areas for our Messier marathon next week. But Helen's written here, who is this angelic woman? Is she the Egyptian goddess Isis, throwing heads of wheat across the Milky Way? Oh, that's cool. Is she Astrea, the goddess of justice, weighing the good and evil of man on the scales that appear nearby? Okay, going to look forward to that one, Helen. Anyway, that is in an hour and a half's time. But what have we got tonight in our Practical Astronomy series? Well, at the request of a number of members, we're going to be covering a couple of related topics tonight. And the first one is going to be setting up a coordinate mission to comets, asteroids, and other objects as well. And the related subject is we're also going to walk through how to set up an image mosaic to capture Mars, if you remember, is passing between two Messier objects next weekend, the Lagoon and Trifid Nebula next weekend. And then, of course, we'll also be hopping over to the discussion boards to cover any questions that you've got. I know Dave Larkin's got one there about the new seeing measurement that we're using. And don't forget, if you've got any questions for me tonight, just post them over in the live cast thread on the discussion boards. You can find that through community, and you can go up here to featured threads or whatever. And if you hop over to courses, then you'll see Practical Astronomy with Paul Cox, and you can, when my machine catches up. Oh, Cara maybe has popped another question in, so we'll take a look at these next week. Oh, Paul, tonight cast has a bunch of echo with your audio. Okay, hold on 1 second. I will try and do something about that. So thank you very much, Cara. Hold on 1 second. Okay, I've adjusted my audio level a little bit. Doesn't sound like it was feedback, but sorry about that. You know what Windows does, it gave me an update and then all hell breaks loose with your audio settings. So I'm just waiting to hear if this comes in any better, because I know how frustrating it is listening to dodgy audio. So 1 second. that sounds okay. Totally good. Thank you, Cara, for pointing that out. We often message SLU staff, often message us if we have a problem. But anyway, hopefully that's better. So we can hop over there at the end of the live cast and see what questions we've got. But before we get on to the first of our topics, let's do our usual kind of quick peek at what's going on in the community. Now let's start off with the observation log timeline here on the home page to see some of your best images that you've been sharing. Now here's one. Now if this one says it's Bode's Galaxy, and Nicole B shared this, and she's highlighted this as SLU art. Now if you're a new member or you're an old member who hasn't heard of this before, SLU art is an image that's gone a little, how can we say, wonky, but still looks pretty cool. And that's exactly what's happened in this one. This looks like it's from the half-meter telescope. Looks like it's probably a bit wind blown, and then it hasn't managed to align all of the red, green, and blue filters on there. But so that's a nice bit of SLU art. But what else have everybody been sharing? Oh, that's nice from Chili. Chili has been on fire lately. It really has been producing some really cool images. And that one's NGC 6357. Is that the cave? Not sure. Anyway, let's go through. Oh, that's a cool one as well. Got a bit of a colour tinge on that set. May have been taken when the moon was out. Sure, that looks like dark nebulae to me, that one. Oh, and that's very much a dark nebulae. Oh, that's the Pipe Nebula. Okay, so I've heard of that, but never seen of it before. And that's this incredibly rich star field. So it looks like it's probably in the Milky Way. And those patches of black are not where there aren't any stars. It's where there's a huge, thick cloud of dust, which is actually obscuring the starlight behind it. So and that is kind of pipe shaped, so maybe that is what that's referring to. Let's just hop back, because there was another cool one I saw a bit earlier. A few people look as if there's another planetary nebulae. That's from Jay, and it looks like there's quite a few people at the moment kind of chasing down these planetary nebula, and that those, if you remember, are kind of sun-sized stars at the end of their life, kind of shrugging off their outer layers, and they form planetary nebulae. Now this is Mars through the Canary 4 telescope. Now I think we're just entering the period at the moment where we're going to start seeing some detail maybe in Mars, in our Mars images, because it's still very, very small. So it's quite difficult to see in Chile at the moment, but that's looking to me like in Canary 4 that we might start seeing a little bit of detail. And that was Jupiter in Canary 4 last night as well. Been tweaking the focus on that system. Oh, look at that. Oh, that's nice. Joe D, thank you very much for sharing that. Southern Pinwheel Galaxy. So this is one that we're going to see next week during the Messier Marathon, Messier 83. Now, that, frankly, is an astonishing image. The clarity of that is absolutely stunning. Now, if you've been watching Dr. Paige Godfrey's Intro to Astronomy courses, she did her galaxy classification, and this to me looks like an absolutely classic barred spiral. So you can see it's obviously a spiral galaxy with its arms spiraling out, but what you can see in this middle area, just outside the core of the galaxy diagonally, is a straight line, and that's the bar. So it's a barred spiral. That is a stunning image. That really is beautiful. Now, hopefully we're going to get images like that next week during our Messier Marathon. But anyway, let's hop over to the discussion boards quickly, see what's been going on over there. And I think there was one down here about querying how many missions. Here we go. 5 missions a month. So this is Richard P, and it's a query I received quite a bit from new members. It's about the differences between an apprentice and astronomer membership. So Richard P, he recently upgraded from apprentice to astronomer, but he didn't immediately see the difference between the two types of account. So kind of what are they? Let me just do a quick check. Yeah, we're still on air. That's always nice. So what are the differences? Well, there are two main items that change depending upon what membership type you have. One is your reservation quota. That's how many reservations you can set up, how many missions you can book on the telescopes, and also the number of piggyback missions you can have. And that's if you go to the scheduling pages, that's where you press the auto save to my pictures on another member's mission. So an apprentice member gets 5 reservations per month where they can book the telescopes, and they get 1 piggyback mission at a time. So you can set up one of those. So you can go to the schedule. Let's hop over to there actually now. Hop over to the schedule and go to the telescopes, and you can see down here. So if you're an apprentice member, you'd be able to do one of these auto save to my pictures at a time, and as soon as that mission's finished, then you can press another button. But astronomer members, well, they have no monthly limit, no weekly limit to the number of reservations that they can book. The only limiting criteria on that is that you can't have more than 5 missions set up at any one time. In other words, 5 concurrent missions. But as soon as your first one runs, it releases that quota and you can book another mission. And also astronomer members can do 5 piggyback missions at a time as well. But once again, there's no limit as to how many of those you can do each month. So Richard, there you go. There is a huge benefit in having an astronomer membership. Now, of course, there are other benefits to an astronomer membership as well, like you can choose the telescope, you can choose the date and time, you can choose your processing options to use, and you can also set up coordinate missions. And that's something that we're going to be looking at this evening. But let's just take another quick peek in here. Because one aspect actually of SLU that I have always enjoyed over the last 14 years is watching new members join and then develop their interest, knowledge and skills. And it might be someone who starts with no knowledge of comets or asteroids when they first join, but then they start setting up coordinate missions to comets and asteroids, like we'll do later, and then maybe even graduate through SLU's near-Earth object training program to become a fully fledged member of the A-team, making regular submissions to the Minor Planet Center, and even working with professional astronomers in what are called pro-am collaborations, like the ones we've seen over the last few years, a lot of the Comet pro-am campaigns. But another example I love to watch is someone who wants to start out doing their own image processing. It's always so enjoyable for me to watch how quickly members progress with the kind of help and guidance of more seasoned members. And the latest member I've been watching on their journey of kind of exploration and discovery is Zenith Wu, who only joined, I think it was last month, but Zenith did everything right. He got straight into conversing with other members in the discussion boards, taking advice, but most of all, jumping in at the deep end. So let's just take a look, because I think he's got a couple of posts here which are quite cool. Did I miss one already? No, there's a problem there. Here we go. So there's one here, and there's another one here. So let's have a look at this one first. Make sure that you can see that. Yeah, we can. And this is Zenith. He's saying it's his first processing of a Canary 1 half-meter telescope image, and this is a Pinmore Galaxy. And look at this! I mean, this is for a first attempt. It's just absolutely superb, and I particularly like the color. You know, because a lot of astro processing is about personal preference, and one of my preferences, I do like deep sky images of nebula and galaxies and star clusters and stuff with a bit of color boost on it, and Zenith has done just that. And there's another one here as well, and this was Messier 100. So that's looking pretty cool as well. So I'm going to keep a very close eye on on what Zenith gets up to. And actually, I remember talking about people who have absolutely flourished. I remember the leader of our CATS Comet monitoring group, Christina Feliciano. 3 months after joining, she finally plucked up the courage to post a question. And a couple of months later, she told me that she really regretted not doing that earlier. Christina, she joined SLU with nothing more than an interest in comets. She was just fascinated by them. But within a couple of years, she was leading 2 of SLU's Pro-Am collaboration projects with professional astronomers around the globe. And her only regret was that she didn't ask the community sooner. So listen, don't be afraid to put your head above the parapet in the discussion boards, and you'll have already seen that it's an incredibly friendly and supportive place to learn astronomy. And I truly believe that's because all of us members remember how daunting we found the subject when we first started out. So I certainly never let that leave my mind. Anyway, let's get on to our first topic tonight, which we've already mentioned a couple of times, and we're going to look at how to set up a coordinate mission and why you'd want or even need to. Now, I've had several members ask me how to set up coordinate missions for asteroids and comets specifically, and really one of the main questions has been how they establish the coordinates of an object for a particular time. But first of all, let's ask ourselves the question, why do we need to do this for comets and asteroids, but not for other objects, such as deep sky objects? If you hear people talking about DSOs, they're deep sky objects, basically nebula, galaxies, and star clusters. Now, let's take a look at our planetarium software for this. So let's call this up. I'm actually remembering, look, to change windows this week. There we go. If you remember last week, I was sharing a lot of things with you and actually forgetting to change the screen. Now, here we go. This is the SkyX, and most planetarium software is roughly the same. So let's do a search for a galaxy that was my very first target when I used a CCD camera, the Whirlpool Galaxy, Messier 51. And let's just pop in here, the search. Wow, that was a night to remember, I'll tell you. I went in big when I discovered you could hook up a telescope to a computer. Never owned a telescope before. Scared on, didn't think I'd managed to find anything in the sky, but I bought a Meade LX200 10-inch telescope, and that was a major purchase, And my very first night saw it voice controlled. I remember the excitement of standing outside in the darkness saying, "Slew to Jupiter," and the telescope whirring into action, then looking through the eyepiece at Jupiter for the very first time. Not many people do that, do they? Most people have peeked through a telescope at some point before doing their own. But anyway, after looking at a few kind of globular clusters, I soon realized that it was all but impossible to see any detail in the vast majority of celestial objects. Most were faint, fuzzy patches. So within a week, I had purchased my first CCD camera, and once again, jumping in at the deep end. I didn't start off small. The first series of images I took were of the Whirlpool Galaxy, and within 5 minutes I'd processed my first color image. But let's get back to coordinate missions. So let's have a look. There's M51. Let's frame M51. I'm just going to turn it up so that it faces the same way that we present all SLU images. And we'll zoom out a little bit so we can see some of these. So let's have a look, see what we're doing next. So if you look over here in the left-hand panel, you can see that we've got the coordinates of the Whirlpool Galaxy. Now I'm just going to lock on to the Whirlpool Galaxy, and let's I'm just going to stop the time, and let's hop forward an hour and keep your eyes not on the galaxy, but keep an eye on the coordinates. So we can hop forward an hour, we can hop forward 2 hours, 3, 4, 5, 6, 7. The coordinates are not changing. How about if we change the day? Hop forward on those. No. Hop forward on the month. No, these coordinates are not changing. Let's even try it year to year. So M51, those are the coordinates. Change it the next year, the next year, the next year. The coordinates are not changing. To all intents and purposes, and certainly over our lifetime, deep sky objects such as galaxies, nebulae, and star clusters, they don't move against the background stars, the celestial sphere, in other words. But now let's hunt down a comet and see what happens. Now, I want to search for, I saw a mission to this the other night, and it's looking pretty good at the moment. It's which one was it? It was N6. So this is a comet C 2016 N6 Pan-STARRS, and there it is, high up in the north at the moment. So let's just frame this. I'm just going to stop our computer clock, turn this around the same way. So there we are. You can see these rectangles. They actually represent the SLU telescope field of views. So let's just zoom in a little bit, zoom out, zoom in a little bit, and there we can see our comet. And let's do the same thing that we did before. Let's hop forward a minute and keep an eye open on these coordinates over here. And let's hop forward a minute. The coordinates changed, and you may have even seen the comet move slightly. If we do it on an hourly basis, that change becomes even more obvious. So look, over the course of a few hours, that comet is moving against the background stars to cross the entire field of view in one night of the Canary 4 system. And of course, if you changed it on a day-to-day basis, it hops well outside of this field. So the general rule is that the closer an object is to Earth, and don't forget comets and asteroids are in our solar system, the faster its apparent motion across the sky is going to be. So basically any object in the solar system is going to move against the background stars, meaning their coordinates change depending on the date and time. Now, we're saying about the solar system, let's do another search. Let's search for one of my favorite planets, Jupiter. Okay, so keep an eye on its coordinates. Let's center it on the screen. Keep an eye on its coordinates. Is Jupiter going to move over a course of minutes? Not so much minutes, but let's see hours. Yeah, okay. They're changing, but very minutely. How about days? Bang. Then you can see Jupiter moving against the background stars. So there you go. Now we can see that it actually moves against background stars from night to night, and all the planets do the same thing, although at different rates. It's no surprises that the outermost ice giant planets, Uranus and Neptune, have a slower apparent motion than the inner two rocky planets do, Mercury and Venus. So, but let's see how this affects our two main celestial quarries when it comes to setting up coordinate missions, asteroids and comets. Now, I think we'll hop over to the JPL website. So I've just got to change a couple of things on my screen. Actually, no. While we're in the Sky software, we'll take a look at this. No, we won't. No. So I was right first time. Let's excuse me while I just close the Sky, open something else up for you. So hopefully you can see this. And we're going to hop over to one of the JPL sites. So here we go. This is showing us near-Earth object close approaches over the next little while. And let's take a look. Listen, here's one. This one's actually making a close approach later tonight, 2018 EF1. So let's use that as our example tonight. And we're going to use two different ways of establishing the coordinates of near-Earth asteroid 2018 EF1. We're going to use our planetarium software, which is actually my preferred method. I'll tell you why later. But we can also use the JPL Horizon system, which kind of can look complex, but is actually quite easy when you know what inputs it requires. So let's do the sky first of all. So we'll hop back over to the sky, and there it is. Now I'm using the sky, but most planetarium software is fairly similar. So what I'm going to do is come up here to inputs and down to small solar system bodies and asteroid small database, and I'm going to add this one by name. So it was 2018 EF1, and this is now going off. It's getting the orbital elements for that asteroid from the JPL website, and it's now loaded it in our planetarium software. So I'm just going to set the to computer clock and stop that again, and then we can do a search on this 2018. I can already see where it is. There it is. It's the little red dot over there. So here we can see that that's where the asteroid is, and here are the coordinates. Now we need to use what are called J2000 epoch coordinates. Now, so whatever source you're using, just make sure that you're using wherever it says J2000 or 2000. And you can see here, these are the coordinates. And these are the coordinates at this specific time. So what we'd really want to be doing is checking to see how fast this little blighter moves, right? And the best way of doing it is actually why this is my preferred method to do it, because you can kind of judge how accurate you've got to be based on how fast moving each asteroid is. So there it is in our fields of view. I'm just going to change the time on this so we can get out to the hour and center it. So let's just move forward a minute at a time. 1, 2, 3, 4, 5. You can see there's actually quite a lot of movement there. I'm just going to go back. Let's have a look to see how much it moves over an hour. Wow. I mean, that could hop straight out of our field of view, couldn't it? Over an hour. So we want to be, I would say, within 5 minutes accuracy to ensure that we're getting this. And sometimes if I'm going to take a series of missions, let's say we were using the Canary 1 telescope, which is the smaller of the two squares that we can see here, I would choose the time. Let's say we were going to do a mission now at midnight and also at 20 past midnight. I'd normally set this to be in the middle of those, right? Center, use those coordinates, and then look what happens. My first missions at 00, the asteroid would be there, and then at 20 past, it would be over there. And that's actually quite a cool way of doing a time lapse, because it means that the star field behind is going to stay the same, and you'll see the asteroid move across it. So anyway, that's why this is my preferred method. So what I also do actually here is I usually change the way the sky shows the coordinates. At the moment, this is what's called sexagesimal. Sexagesimal just means, of 60. So this is showing us that right ascension is 6 hours, 48 minutes, 42.3 seconds. It's showing us that declination is 45 degrees, 8 minutes and 44 seconds. So, but you can save when we go over to the reservation page. You can type all of those in, but that's 6 individual entries that you have to make. And with every single entry that you make, you stand a chance of a typo, and you don't want a typo in your coordinates because you're going to miss your target. So I right click on these in the sky and say change coordinate format to decimal. So here we can see we've now got both of these values, not in sexagesimal, but we've got them in hours and degrees decimal. And that means all I've got to do is right click on that, say copy the RA, and I can paste that straight in to the coordinate mission boxes when we're setting up our reservation. So that's how I do it. So we'd be setting our time, we'd be grabbing these. That's how we do it using planetarium software. But Now let's hop over to what's called the JPL Horizons website. I'm going to switch over to that now for you. Hopefully you can see that now. Transition. There we go. So this is the JPL Horizons website, and this is the other method that I know a lot of the A-team, a lot of our comet and asteroid hunters, they use this very system. Now I'm just going to increase the size of this so you can maybe see it a bit better. And there are a bunch of options. This might look complicated, but actually as soon as you know what to put in each one of these, what is it, 7 entries, 6 entries, right? It's really, really simple. So observer, we leave the same. Target body, you press change, and we type in here 2018 EF1 is our target. We'll do a search for that. Couldn't find it. Oh, that's because I think it wants capitals. It did, it wanted capitals. Well, that's worth knowing. And then we've got the, and you can see here, it's picked it up. If there are a bunch of objects using, kind of similar terminology, which wouldn't be possible really for asteroids, it might give you some options. But then we want the observer location. And that's quite important to get right. And our planetarium software, by the way, was of course set up for the Canary Islands. So in here, you don't have to know what are called the Minor Planet Center observatory codes. I do know them, but all you got to do is type them in here. And it's showing us that there are 2 observatories with the word SLU in them. And you can see one here, the Canary Islands Observatory, is code G40, and the Chile Observatory, which is just opening now, is W88. But we're going to say let's use the Canary Islands Observatory, use that selected location, and there you can see we've already done 3 of these things. Now we've just got to do the time span. So let's hop into here. And let's pretend that it was going to be tonight that we were going to do this. So I would normally put in here to span 2 days. So we've got the 11th to the 12th, and the step size, we know this is fairly fast moving. So let's do this on minutes, and use specified times, click that, and you can see it's entered that. There are the two other settings there you don't really need to worry about. The important button here is generate ephemeris, and ephemeris is just the locations of an object in the sky over a period of time. So press that, and back it comes with a lovely table of information. Now let's say we wanted to set up a mission for 10 past midnight. So that's on the 12th. So we're going to hover to, oh dear, I didn't go far enough. Look at that. So let's hop up the top. I should have gone to 13. I should have gone. Bear with me. Use specified times, and we'll click generate ephemeris again. So, oh, actually, I was right. We are on the 12th, aren't we? Oh, dear, I'm not used to the clocks changing. So, in let's say we were going to do a mission at 30 midnight, that's 0030 UTC tonight. So we hop down to the 12th and 0030. We go to that line. Here it is, and there are our coordinates. The right ascension coordinates on the left, and the declination coordinates on the right. Make sure that you always pay notice to the declination plus or minus symbol. If it's plus, you don't need to put anything in the reservation system, but if it is a minus declination, you do need to put that in. So this is a fairly faint object. It's also telling us what the magnitude is 19, so that would be a fairly difficult object to find. But you'd be able to use exactly that same process using exactly that same process for a comet as well. So let's just hop back for a second, because I want to show you how we'd actually do this for a comet, because a comet is, it's exactly the same process as this, but so in this one, I'm going to make sure that you can see here, I've already got some of these comets loaded up, but I want to make sure that I've got the latest data. So I'm going to input, I'm going to small solar system bodies, comets. I'm going to highlight all of those, remove them, then click the observable. So this is going to add. So it's basically hopping over to the Minor Planet Center JPL websites, and it's grabbing the orbital elements for all of these comets, and it's just added them in there. So here we go. There's that comet that we spotted the other day that is starting to look really good, actually. It's very noticeable in the images. So there you go. If you wanted to set up, let's say tomorrow night, so let's hop forward to the start of ops tomorrow. So there it's a bit southerly, so let's step back in time tomorrow night. Okay, so actually it is really far north, isn't it? So maybe 22:20, that's fairly good time. It's far enough away from the transit, so it'll be able to do that. And over here, those are the coordinates that we would enter for our mission. So just make sure you match the time and date up, which is what I didn't do a minute ago. So anyway, hopefully that is a little bit easier than you thought. But if you land up in any problems, then post in the discussion boards. And actually, there's a little video of me doing this, which is a kind of shortened version of what we've gone through tonight. And it shows you all those steps in using the JPL Horizons website. But another recent question I promised to answer also requires the use of coordinate missions, and it's setting up mosaics. Now, mosaics are a method used by members to capture objects that are too large to fit within a single field of view of a particular telescope. So let's just search for a big object here. Let's take a look for M31. We'll step back in time so it's up in the sky a bit, and we'll frame this so we can see the slew fields of view here around the Andromeda Galaxy. Let's zoom in a bit. So don't forget, these rectangles are the fields of view of the different telescopes. So the small rectangle in the middle, that's the Canary 4 Solar System telescope, which shows you why it's good at doing small objects like planetary nebulae, well, small planetary nebulae, and planets, and close-ups of the moon. Then the two squares in the middle, that's Canary 1/2 meter telescope field of view, and then the outer one is the Canary 2 wide field telescope, and then the two outer rectangles are the Canary 2 ultra wide field telescope and the Canary 3 deep sky astrograph. So those are our two largest fields of view. The Chile 1 ultra wide field is roughly the same size as well. And you can see that even with those enormous fields of view, the Andromeda Galaxy doesn't fit entirely within the field of view of those. I mean, that's the outer edge of the, in fact, no, we'd have to go even further. You might not be able to see this on your screens, but there's the very outer arm of the Andromeda Galaxy is right here at the top of the screen. So it's just within those massive fields of view. But look, we're missing over half of the Andromeda Galaxy below. So why would we want to use a coordinate mission to be able to do something like this? Well, it's about setting up the mosaic, because if we set up a mission to the Andromeda Galaxy, Messier 31, the slew telescopes are going to center it right there where you see that spot, which means that for most of the telescopes, we're just going to see the central core. And even our biggest field of view telescopes, we're going to miss the outer extremes. So what we want to do is set up a mosaic. Now, Dave Larkin has a long-time member, hunts down all the best free software to use. And Dave has written a little how-to on one of the tools that he uses to get the coordinates for each mosaic panel. And this will make sense in a second. But I'm going to use the sky, because the sky's got a handy little utility in here. And the first thing I'm going to do is, let's assume that we're going to use the Canary. Let's do the Canary 2 ultra wide field. Actually, no, let's use the Canary 3 deep sky astrograph. So I'm going to turn off the other fields of view so we get some clarity. And you can see here the Canary 3 deep sky astrograph has a field of view of 1.5 by 1.25 degrees. To put that in context for you, let's take a look at a familiar object in that field of view. That's how big the moon would appear in the Canary 3 field of view. So you can see kind of roughly how much size, or the apparent size of Andromeda. It's kind of 4 times the size of the moon in the sky. And you can see some of that in the just through binoculars as well. But anyway, we're going to use the this little tool up here. So tool mosaic grid, and it's going to hop over to the last one that I set up. And actually this one is what we're setting up for next week. And actually just remember this one, because you can see here there are 3 light blue cyan rectangles here, and one of them has A1, the other one says A2, the other one says A3. That is a 3-panel mosaic. We'll take a look in the discussion boards that we're setting up for next week for Mars. If we do a search on Mars and we change the date to next week, we can see Mars just appearing in the left-hand side. And over the course of 3 nights, Mars is going to travel between the Trifid Nebula, which is the nebula in the top, and the brighter nebula down the bottom, which is the Lagoon Nebula. So to capture all 3 objects, we're going to be setting up a mosaic for that. But anyway, let's get back to our mosaic for M31. So I'm going to get M31 up, and I'm going to say get the center of the current chart. That's where we want to put our mosaic. And we're going to say which telescope we're going to use. So my fields of view, Canary 3 deep sky, get tile geometry from my field of view. So you can see there straight away it's taken the field of view for the Canary 3 deep sky telescope, and it's created 3 panels. But you know, let's be a bit stingy with this. Let's say that we can only do a 2-panel mosaic to capture it. So just down here in mosaic geometry, it says rows 3. I'm going to reduce that to 2, and columns 1. If I went up, you can see what happens. It's just adding more and more mosaic panels based on the field of view that we've said use. And you see another thing down here. There's what's called overlap. Now I like to use a lot of overlap on my mosaics when I'm setting up, but you know, on this one we could maybe afford to reduce this to maybe 30% overlap, and that just means, so let's take a look at this box a second. Right, so we've said we want 2 rows, 2 panels in 1 column, and overlap those panels by 30%. So that's what it's giving us. So this one panel up here is A1, and it gives us a center point of that, and the bottom panel gives us A2. We can move it around, we can reframe it, and then say get center from the chart again. But what we're really interested here is, okay, what are the coordinates that we need to use to image both of those panels, A1 and A2? And if we hop over to here, we can say, in fact, I don't think I'm going to be able to show you this because, unfortunately, in here, we've got a little copy to clipboard. Actually, what that's going to do is it's copied the coordinates of both of those mosaic panels, A1 and A2, but I can't show you that on my screen, unfortunately, which is a bit of a pain. We might be able to select it though. So there you go, mosaic A1. So there you can see it's given us the coordinates for that particular panel. So what we do is we'd set up 1 or 2 missions using those coordinates, and that would capture the northern half of the Andromeda galaxy. We'd then set up missions to the A2 panel using these coordinates, and then when we gather up all of our data, we can use any kind of image processing software, it doesn't have to be fancy, to basically piece them together just like a jigsaw. And because we've given us that large overlap, it actually makes it a lot easier on a mosaic when you use a large overlap. So anyway, that's what we're doing, and it's what we're doing, as I say, for Mars next week. So if we hop back to that, let's just center that, and there you can see on these 3 nights, oh, this is going to be so exciting, especially having it happen on the night of the Messier Marathon as well. There is Mars in the center of that image, and it's going to be passing between the Trifid Nebula up here and the Lagoon Nebula down there. So what we're doing there is, over 3 nights, we're going to take a whole series of images of those 3 mosaic panels. So not only can we create a mosaic image that shows all 3 objects, but we'll also be able to create an animation time lapse from those combined mosaic images. So anyway, I hope that makes sense. Don't be scared off by any of that, because it is, you know, a lot simpler probably than I've just explained there. But anyway, that was the Sky Mosaic tool. And don't forget, let's just hop over to the discussion boards, because over here, in fact, let's just do a search for Lagoon, because what we've got in here is a post where I've actually given you the coordinates for those 3 mosaic panels. So if you want to give this a go, like Jay and Cara are going to, I believe, those are the coordinates to use, and there's a little bit more explanation in there as well. And here's a little animation to kind of make sense of it. There are 3 panels, A1, A2, A3, with a 50% overlap, and there's Mars skipping through between those 2 nebula, and they are beautiful nebula. They always show up beautifully. So and it's showing them Mars skip between the 2. So if you've got any questions about setting up a mosaic, ask them over in the discussion boards, and also hunt down, maybe Dave Larkin actually can put a post in the in this live cast thread to some of his tutorials on some of the free software that Dave uses for setting up mosaic software. Anyway, before we finish up tonight, let's take a look, see if there are any other questions on here. And Dave was asking a question here, and he's noticed the new seeing conditions on the telescope pages. So we'll take a quick look at those, and I'll show you where this is. We'll hop over to the Canary 2 telescope page. What Dave, oh, look at that, there's a bit of a shutter problem there with the CCD camera. But what Dave is referring to is this panel over here. Seeing conditions, atmospheric conditions impact image quality, it says. And the setting at the moment is 5, and it says more continuous distortions with short intervals of good seeing. And that's what we've set the seeing to tonight. Let's take a look, see what's over at Chile. So Chile's come online. What are we looking at in Chile at the moment? Ooh, 2 nice clusters of stars by the look of it. Very nice. NGC 2006. Anyway, I'm going to snap an image of that. That's quite cool. Nice colours in that, aren't there? There. Take a look at the ultra wide field and see what it looks like in there. Sorry, you know me, I'm like a kid in a candy store. Oh no, we missed it just before I was going to show you. There was a satellite that had obviously gone through that. So let's take a look here, and you can see here that the seeing condition panel is here, and tonight the Chile Observatory is actually being assessed at having a better quality sky than the Canary Islands, because if you see the all-sky camera in the Canary Islands, it's actually quite hazy at the moment. But you can see here, this is set to 7 intervals of perfect seeing with fine scale distortions between. So that means that some of the planetary images will be especially good later on. But what are we looking at here? Keith Smith, what are you looking at, Keith? And you see 2007. Okay, so Keith's going through the numbers. 2006, first of all. 2007 now looks like a couple of galaxies appearing to me. One in the center and one a little bit further down. Anyway, listen, what is seeing? Let's just remind ourselves of what seeing is. Well, it's the quality of observing conditions related to the turbulence in Earth's atmosphere. And the best seeing conditions are usually found at high altitude in locations where the air mass has traveled across smooth terrain or topography, such as an ocean. And it's no coincidence that two of the best astronomical observatory sites in the world are located high on volcanic islands in the middle of the sea. And one of those is obviously our flagship observatory in the Canary Islands, home to the largest optical telescope in the world, the Grand Tecan. I went in there once with some of the pro astronomers who were up there. Wow, that is a beast of an instrument. It's over 10 meters in diameter. That's its main optics. But back to seeing. How is seeing measured? Well, actually, I've got a couple of little screenshots I can share with you here. So let's take a look at this one. So this is a little image that I put together of two images of Jupiter, and taken not very far apart in time. Nothing else had changed in the telescope, but what had changed was how turbulent the atmosphere was. And you can see just how much difference it makes, and it does make a huge difference actually to planetary and lunar imaging. And I've got a lunar example here as well, and this once again is minutes apart, but you can see here on the left, you know, the seeing was appalling, and the moon looks blurred and it looks out of focus. But on the right, a few minutes later, exactly the same focus position, everything else was the same, but there was a moment of perfect seeing where the air was stable, and that's what we managed to capture in that right-hand mission. Now I'm just going to pop this up on the screen. So, you know, at its base level, seeing is about measuring the angular size of stars, point sources of light. That's what stars are. Now imagine a perfect night with superb seeing conditions. The photons coming from that star enter the telescope and hit the CCD chip in the camera. Now under perfect conditions, the angular size of the star is small, maybe only spreading out the atmosphere, only spreading out its light across a couple of pixels. And that's kind of representative of the right-hand side of this bar chart. But imagine a turbulent night when the atmosphere is writhing. And this actually often happens at the beginning of the night before the ground's cooled off, because you get a lot of turbulence, kind of heat convection coming off the ground and in fact off the equipment itself. But while the atmosphere is writhingly turbulent, the light from the star is scattered by that turbulent air and spread across far more pixels, making it appear blurry, like the left-hand side of this chart. Now, this is actually measured. Seeing is actually measured using something called the full width half maximum, which is measured in arc seconds. Arc seconds is a measurement of angular size. Now, I'm not going to delve into that for now. We're going to cover that when we do our astrophotography courses and image processing courses. But you know, what we've adopted for our system at the moment is the Association of Lunar and Planetary Observers Seeing Scale. And it's a scale of 1 to 10, one being actually the opposite. No, it is like this. This is a good depiction of it, actually. One is very poor images, impossible to see details or to sketch anything that you're seeing through those kind of conditions. Going into the middle range, more continuous distortions, but with short intervals of good seeing. And then you hop up the scale over to that right-hand side, number 9 and number 10. Perfect seeing with steady images at high magnification. And that's what you want for planetary imaging. All right, so that's the scale that we're using at the moment. But the real news here is that we've introduced this because we're going to be installing new seeing monitors at both observatories later this year. Now, those instruments take continuous images of a star. In the case of the Canary Islands, the instrument is fixed and uses Polaris as its star. And it measures the full width, half, maximum, how spread out that star is on the little CCD chip, and reports the results in arc seconds. And it's also going to graph those measurements. So when you're on the telescope pages, let's just hop back over to that. When you're on the telescope pages, it's going to be down here with all of the other conditions here, so that you can see. Let's take a look, current conditions, stuff like that. It's going to be in here, so you're going to be able to see that. But not only that, what we're planning to do, let's hop up, actually, take a look, see what... oh, Keith, yeah, you're on a roll tonight, Keith. So you've done 2006, 2007, and 2008. So 2007 must have been that little galaxy. Let's make sure you can see this. The little galaxy up here. And 2008 must be that little one in the middle. Looks like a spiral galaxy. Faint spiral galaxy. Anyway, what we're planning to do is we're going to log those seeing measurements, and other weather telemetry and moon proximity and phase with your mission images. So imagine hopping over to My Pictures, and with every single bit of mission data in My Pictures associated with it is going to be how good the seeing was during that mission, how bright the moon was, how close the moon was, plus a whole stack of other weather telemetry. And we're even considering adding a little all-sky camera snap so you can see the sky conditions at the time of your mission. So, tell us over in the discussion boards if you think that little lot is going to be useful. But anyway, listen, that just about wraps up this week's Practical Astronomy livecast. I'm just going to hop back to the telescopes. I'm going to hop back to Keith's Chile mission. Actually, no, let's take a look at Canary 3, see what Canary 3 is up to at the moment. Spiral Galaxy M94, Messier 94. So I hope you're all getting excited for next week. Is the moon up? It's looking a bit green, isn't it? We have got some haze there tonight in the Canary Islands, but yeah, you can see how much haze. That is a very hazy night, and that's why the seeing conditions are marked down. You can also see here actually that we've slightly closed Dome 1 and Dome 3, the one in the background over there, just to give a little bit of shelter because it is quite windy there tonight. But anyway, listen, don't go far because Helen Avery is going to be on air at 9 p.m. That's half an hour's time, 0100 UTC, with the latest episode of her Constellation Stories. And if you weren't with us at the beginning of the show, we can hop over, go to livecast, and then you can go to the show. Helen is talking about the constellation of Virgo, which, as I said at the top of the show, I know very little about. So I'm going to stick some dinner in the oven and listen to Helen in half an hour's time. By the way, Helen, great to have you back. We missed you last week, and I think it was the week before. Sunday nights just aren't the same without you. But anyway, also, make sure you join me tomorrow night, Monday. It's quite early, 5 p.m. Eastern EDT. That's 2100 UTC for our postponed countdown to the SLU Messier Marathon. So once again, you can find out more details here, live cast, and then you can hop down here who count down to the Slew Messier Marathon, and I'm going to be explaining exactly how you can get involved with the observing event of the year, which is next Saturday, 17th March. We're going to keep an eye on the weather forecast. If you don't know how to do that, go to the telescope pages. Let's hop down to Canary 2, take a look at that one. Hop down the page. Ooh, that was nice. Ooh, M101, missed it. We can go to the weather tab, and then there's our forecast. Saturday 17th, light cloud, so still got plenty of time for that to change. But don't forget that if we are weathered out on the Saturday night, we are going to shift everything to Sunday the 18th. Oh no, we haven't missed. Oh, look at that. Oh, I love the Pinwheel Galaxy Messier 101. And that, if you remember, is what Zenith was using for his one of his first image processing attempts. Very well done, Zenith. Really enjoyed watching that. So anyway, don't miss that show tomorrow night, where I'm going to be explaining to you exactly how you can get involved with the Messier Marathon next weekend, Saturday the 17th, which is going to start 10 minutes before the Canary Islands Observatory comes online. We're going to be using both observatories for that Messier Marathon. And please come along and join us, because it's going to be an absolute hoot. We might even get some members on air joining us on air while we watch all of the live images coming in of all 110 Messier objects. So anyway, join me tomorrow night for that. But that is all from me tonight. Helen Avery is on in half an hour's time. I'm Paul Cox, and this has been Practical Astronomy with Slew. I'll see you tomorrow night. Bye for now. Heads of wheat across the Milky Way. Oh, that's cool. Is she Astrea, the goddess of justice, weighing the good and evil of man on the scales that appear nearby? Okay, gonna look forward to that one, Helen. Anyway, that is in an hour and a half's time. But what have we got tonight in our Practical Astronomy series? Well, at the request of a number of members, we're going to be covering a couple of related topics tonight. And the first one is going to be setting up a coordinate mission to comets, asteroids, and other objects as well. And the related subject is we're also going to walk through how to set up an image mosaic to capture Mars, if you remember, is passing between two Messier objects next weekend, the Lagoon and Trifid Nebula next weekend. And then, of course, we'll also be hopping over to the discussion boards to cover any questions that you've got. I know Dave Larkin's got one there about the new seeing measurement that we're using. And don't forget, if you've got any questions for me tonight, just post them over in the livecast thread on the discussion boards. You can find that through community, and you can go up here to featured threads or whatever. And if you hop over to courses, then you'll see Practical Astronomy with Paul Cox, and you can, when my machine catches up. Oh, Cara maybe has popped another question in, so we'll take a look at these next week. Oh, Paul, tonight cast has a bunch of echo with your audio. Okay, hold on 1 second. I will try and do something about that. So thank you very much, Cara. Hold on 1 second. Okay, I've adjusted my audio level a little bit. Doesn't sound like it was feedback, but sorry. Hello, slewers, and welcome to Slew's Practical Astronomy series with me, Paul Cox, where we're going to learn to explore space together and get the most out of our Slew membership. So welcome to everyone this evening. Well, it's this evening here anyway in Connecticut, here at Slew HQ. So I know we've got listeners around the world. Now, if you're somewhere on Slew's website and you're suddenly hearing my voice, hop over to the Situation Room and you can watch the live cast there. So you just hop over here up to Space Situation Room, and there we've got that lovely infinity thing I've got, you know, it's picture in picture in picture in picture kind of thing. Anyway, you can also, by the way, if you are doing other stuff and you want to concentrate without my voice, you can come up to the little audio widget at the top of the page and you just mute me if you like, but hang around and listen if you can, because we're covering some great topics tonight actually, and a lot of people have asked me to cover these particular ones. But before we get into those, don't forget that Helen Avery is going to be on air in an hour and a half. That's at 9 p.m. Eastern. That's 0100 UTC for the latest episode in her Constellation Stories. Now let's take a look, see what Helen is covering tonight. So left-hand navigation, live cast, and you can go down to the page and there's Helen's show. Virgo. Okay. You know, I don't really know very much about Virgo. The only thing I really know about Virgo is how many Messier objects are in the constellation of Virgo and between Virgo and Leo. If you remember, we're looking at that because that's one of the packed areas for our Messier marathon next week. But Helen's written here, who is this angelic woman? Is she the Egyptian goddess Isis? Throwing, you know what Windows does, it gave me an update and then all hell breaks loose with your audio settings. So I'm just waiting to hear if this comes in any better, because I know how frustrating it is listening to dodgy audio. So 1 second. Oh, that sounds okay. Totally good. Thank you, Cara, for pointing that out. We often message, Slew staff often message us if we have a problem. But anyway, hopefully that's better. So we can hop over there at the end of the live cast and see what questions we've got. But before we get on to the first of our topics, let's do our usual kind of quick peek at what's going on in the community. Now let's start off with the observation log timeline here on the home page to see some of your best images that you've been sharing. Now here's one. Now if this one says it's Bode's Galaxy, and Nicole B shared this, and she's highlighted this as Slew Art. Now if you're a new member or you're an old member who hasn't heard of this before, Slew Art is an image that's gone a little, how can we say, wonky, but still looks pretty cool. And that's exactly what's happened in this one. This looks like it's from the half-meter telescope. Looks like it's probably a bit wind-blown, and then it hasn't managed to align all of the red, green, and blue filters on there. But so that's a nice bit of Slew Art. But what else have everybody been sharing? Oh, that's nice from Chili. Chili has been on fire lately. It really has been producing some really cool images. And that one's NGC 6357. Is that the cave? Not sure. Anyway, let's go through. Oh, that's a cool one as well. Got a bit of a colour tinge on that set. May have been taken when the moon was out. Sure, that looks like dark nebulae to me, that one. Oh, and that's very much a dark nebulae. Oh, that's the Pipe Nebula. Okay, so I've heard of that, but never. Hopefully, we're going to get images like that next week during our Messier marathon. But anyway, let's hop over to the discussion boards quickly, see what's been going on over there. And I think there was one down here about querying how many missions. Here we go, 5 missions a month. So this is Richard P, and it's a query I receive quite a bit from new members. It's about the differences between an apprentice and astronomer membership. So Richard P, he recently upgraded from apprentice to astronomer, but he didn't immediately see the difference between the two types of account. So kind of what are they? Let me just do a quick check. Yeah, we're still on air. That's always nice. So what are the differences? Well, there are 2 main items that change depending upon what membership type you have. One is your reservation quota. That's how many reservations you can set up, how many missions you can book on the telescopes, and also the number of piggyback missions you can have. And that's if you go to the scheduling pages, that's where you press the auto save to my pictures on another member's mission. So an apprentice member gets 5 reservations per month where they can book the telescopes, and they get 1 piggyback mission at a time. So you can set up one of those. So you can go to the schedule. Let's hop over to there actually now. Hop over to the schedule and go to the telescopes, and you can see down here. So if you're an apprentice member, you'd be able to do one of these auto save to my pictures at a time, and as soon as that mission's finished, then you can press another button. But astronomer members, well, they have no monthly limit, no weekly limit to the number of reservations that they can book. The only limiting criteria on that is that you can't have more than 5 missions set up at any one time. In other words, 5 concurrent missions. But as soon as your first one runs, it releases that quota and you can book another mission. And also astronomer members can do 5 piggyback missions at a time as well. But once again, there's no limit as to how many of those you can do each month. So I've seen of it before, and that's this incredibly rich star field, so it looks like it's probably in the Milky Way, and those patches of black are not where it's not where there aren't any stars. It's where there's a huge thick cloud of dust which is actually obscuring the starlight behind it. So and that is kind of pipe shaped, so maybe that is what that's referring to. Let's just hop back, because there was another cool one I saw a bit earlier. A few people look as if there's another planetary nebulae. That's from Jay, and it looks like there's quite a few people at the moment kind of chasing down these planetary nebula, and those, if you remember, are kind of sun-sized stars at the end of their life, kind of shrugging off their outer layers, and they form planetary nebulae. Now this is Mars through the Canary 4 telescope. Now I think we're just entering the period at the moment where we're going to start seeing some detail maybe in Mars, in our Mars images, because it's still very, very small. So it's quite difficult to see in Chile at the moment. But that's looking to me like in Canary 4 that we might start seeing a little bit of detail. And that was Jupiter in Canary 4 last night as well. Been tweaking the focus on that system. Oh, look at that. Ooh, that's nice. Joe D, thank you very much for sharing that. Southern Pinwheel Galaxy. So this is one that we're going to see next week during the Messier Marathon, Messier 83. Now, that, frankly, is an astonishing image. That's the clarity of that is absolutely stunning. Now, if you've been watching Dr. Paige Godfrey's Intro to Astronomy courses, she did her galaxy classification, and this to me looks like an absolutely classic barred spiral. So you can see it's obviously a spiral galaxy with its arms spiraling out, but what you can see in this middle area, just outside the core of the galaxy diagonally, is a straight line, and that's the bar. So it's a barred spiral. That is a stunning image. That really is beautiful. Now,